Okay, so you all can see my screen. Okay, so we are going to go through two problems. Okay, so the first problem that we will go through, right, okay, is this problem classrooms. I don't know if you've seen this problem. Okay, so I'll just briefly go through what this question is about. Okay, so this question is pretty short. Okay, it's only a few lines. Okay, but the main thing is that you are given a few activities. Okay, and each activity has its own start time and end time. Okay, and you are also given a few number of classrooms, and you want to find an optimal allocation of each activity into each classroom so that the maximum number of activities can be held. Okay, so for example, in this test case, right, okay, you are given 4 activities and 2 classrooms. Okay, so each activity has this start time and end time. So the first activity starts at 1 and ends at 4. Okay, second activity starts at 2, ends at 9, so etc. Okay, so the best way to allocate the activities, right, okay, is actually just to put 1 4 in one classroom. Okay, then in that same classroom you put 4 7 because they don't overlap. Okay, then you cannot put anything else really. Okay, so you have 2 activities in one classroom. The other classroom, right, you only can either put 2 to 9 or 5 to 8. Okay, you cannot place both of them together. Okay, so the maximum number of activities you can hold is 3 if you have 2 classrooms. Okay, so this seems pretty alright, right? Okay, you just trying to find a best way to allocate different intervals into n number of classrooms. Okay, so this is very similar to one problem that we saw previously. Okay, so the problem that we saw previously, right, if you recall, is actually you're given like one classroom only. Okay, so that question, if you recall, is actually the number of you're given like many intervals. Okay, and you're going to find the maximum number of non-overlapping intervals on one line. Okay, so this is like given as one classroom. Okay, so for example, you have some intervals 4 10, etc. Maybe you have 2 8. Okay, maybe you have 9 12, etc. Okay, 9 12. Okay, so for example, you want to find the maximum number of non-overlapping intervals. Okay, if you recall, the algorithm is quite simple. Is you just sort by the n times. Okay, so you sort by the n times. So the why you sort by the n time, right, is because if you manage to sort by the n time, you ensure that the first activity that you select will have the earliest n time, so that you can maximize the number of activities you can have after that n time. So when you sort by n time, okay, the first activity you get is 2 8, then you will get 4 10, and then you will get 9 12. Okay, so this is pretty good, okay, because right now you can just greedily add in the interval as long as they do not overlap with the previously chosen interval. Okay, so when I select the first interval 2 8, okay, since there's nothing else, I just choose 2 8. So which means my end time is at position 8. Okay, now I can just go on to the next few intervals and just keep selecting intervals that do not overlap. So when do they not overlap is when the start time is bigger or equal to the previous end time. The previous end time that I chose. Okay, so the previous end time is 8. Okay, when I go to the next interval 4 10, right, it overlaps with the previous end time. Okay. Okay, so if it overlaps with the previous end time, right, it means that this cannot be chosen. Okay, it cannot be chosen. So therefore, this one will be rejected. Okay, so notice I still keep the previous end time as 8. Okay, next I go to the next interval, then this one obviously it doesn't overlap because this value is larger than the previous end time. So I can just place it inside. Okay, so 9 12, and now my end time is at 12. So remember that if I'm trying to find the maximum number of intervals that don't overlap, then the algorithm is just sort by the end time. Okay, then you just greedily add the intervals as long as they do not overlap. Okay, so you get the idea, right? Okay, so as long as you add one interval in, you just plus 1. So just plus 1, plus 1, so the answer will be 2. The maximum number of intervals you can have is 2 in this classroom. Correct? Okay, but this question is harder. Okay, this question is harder because this question requires you to have n classrooms. That means it's not just one classroom. The previous variant is you just have one classroom and you want to find the maximum number of activities you can have. So you just need to sort by n time and then just greedily add. Okay, but this variant is harder, okay, because you are given more than one classroom. You can have up to 200,000 classrooms. Okay, so how do I actually solve this? Okay, the idea is very simple. It's actually very similar to this, but you just need to tweak it a little bit. Okay, so how we can tweak it, right, is in this manner. Okay, so the idea is the same. The idea is you need to sort by the end time, and you also want to find the maximum number of intervals that you're able to have non-overlapping. But now you are given n classrooms, which means, right, you don't only restrict yourself to checking for one classroom. You can check all n classrooms. Okay, check all n classrooms. So the idea is, similarly, you have all the intervals, you just need to sort all the intervals by the n time. It's the same idea. Okay, sort all the intervals by the n times. Okay, now what you do, right, is that since you are given n classrooms, now each classroom you mention what is the n time of the previous classroom. Okay, because in the previous algorithm, remember we store the n time of the previous interval that we chose. So at first we chose 8, right? The n time was 8, so we store it somewhere. Then the n time is 12, then we store that number somewhere. Now you need to do that for all the n classrooms. Okay, so what data structure should you use? Okay, there are multiple data structures you can use. Maybe the most intuitive data structure is just an integer. Okay, so every classroom you just have an integer to represent what is the previously chosen n time. Okay, so what you can do is that you have n classrooms, right? So let's take, for example, you have 5 classrooms. Okay, so each classroom at first has 0 inside, because this represents the n time. Then if you select the first classroom, then what you do is that you just replace this value with the n time of the interval that you chose. So for example, the n time maybe is 7, then you just put 7 in. Then now you have a new interval, the n time is 9. Okay, then you just need to check. So remember, if a new interval, right? So for example, I have a new interval 5 to 9. So what do? I just go to the first classroom. Then you check, can I put 5, 9 inside? Cannot, right? Because 5 is overlapped with 7. Because 5 is earlier than 7. So you definitely cannot put 5, 9 inside. So you go to the next one. Okay, 0. 5 is bigger than 0. So you can just put this activity inside this classroom. Then you can put replace it as the n time. Then you just need to repeat this algorithm and just do it like that. Okay, but what is the time complexity of such an approach? Okay, so if you think about it, right, in the worst case scenario, in the worst case, what happens in the worst case? In the worst case, right, you have all these numbers being very large. For example, this is 10 to the power of 8. 10 to the power of 8. For example, every classroom is 10 to the power of 8. And this classroom is maybe 10 to the power of 8 as well. Okay, for example, every classroom is occupied, and all the classrooms end at a very huge number. Okay, but then now you have an activity, okay, that is 1 to 10 to the power of 9. Starts from 1 and ends at 10 to the power of 9. Then what are you going to do? Your algorithm is actually going to naively run through every element one by one to check if you can fit that activity in. But you realize all of them cannot fit, right? Because one is smaller, much smaller than every activity's n time. Correct? So this interval cannot be placed into any classroom. Okay? And what happens if you have multiple of these intervals? Remember, we only sort by the n time, so there's no restriction on the start time, which means, right, for all, in the worst case scenario, all the intervals that you go down will all overlap with every activity in each classroom. But then you are going through an O(n) pass, because you're going to check every classroom each time to check if there's any empty classroom that you can put this activity in. So the algorithm is actually O(n) squared. Okay, O(n) squared, because at every query you need to go through a linear pass in the worst case. So therefore, what happens, right, is that n squared will not pass, because this n is 10 to the power of 5. Correct? So n squared is 10 to the power of 10, which is too slow. Okay, so but the idea is there. Okay, the idea is there, but it's still too slow. So you need to make it even faster. Okay, so what you need to change, right, is actually this step. Okay, this, you might have realized, right, this is too slow. Okay, using an array to store all the classrooms is far too slow. When I see the number 1, right, I want to immediately know, am I able to find a classroom to place this element in? Maybe not immediately, but at least faster than O(n). Because right now, to check if a classroom is available is O(n). So what is the best way to do it? You notice, right, okay, that if I have a classroom, if I have an interval that is between maybe A to B, okay, so if in order to place this item inside a classroom, there must be at least one classroom where the n time is smaller or equal to A, right? Where the n time is smaller or equal to A, then I can place A, B inside. So notice, right, the idea is I want to find a classroom okay, it's very hard to write here. Okay, never mind. I'll just say it out. Okay, whose n time, right? Okay, whose n time is smaller or equal to A, so that I can place A, B inside. Correct? So what data structure is this? You're actually finding a classroom whose n time is smaller or equal to A. You want to find something that is just the next smallest value. the next smallest value. So for example, if A is 6, okay, then you have maybe 2, 3, 4, 5, 6. Then which number do you want to select? Obviously, you want to select 6, right? Okay, because 6 is the next value that's smaller than 6 here. So this AB can be placed into this classroom. But then if you only have 2, 3, 5, 8, for example, then if this A is 6, right, then you want to place A inside the 5, because 5 is the available classroom where you can place A, B inside, and 5 is also the largest possible value. So this idea, right, is a tree map or tree set. Okay, basically you have a balanced binary search tree, okay, that allows you, right, to obtain the next smallest value from 6. Okay, so if you recall from your, okay, actually you can't recall because there's no lab this week. Okay, so lab next week you will learn that a tree map or tree set has a lot of methods. There's a lower method, there's a higher method, there's a ceiling, okay, and there's a floor. Okay, in other words, basically it just means, right, all these are already inbuilt. Okay, so you can just call them to find the next smallest value. So if you call maybe dot lower, then it tells you what is the next element that is just lower than 6. So very nice, you can just call it. Okay, you don't need to implement it yourself. So it will tell you, oh, the next smallest value is 5. Then you just select this classroom to place this activity in. Yeah, so this method is O log n. Okay, because this is a balanced binary search tree. Okay, this is a tree map or tree set. Okay, in Java it's already balanced, so you don't need to worry. It's basically O log n. So if each query is O log n, you have n queries, then the complexity is n log n, which will pass this. Okay, so this idea is also maybe a bit hard to grasp. Okay, so let me just give a more concrete example. Okay, then you will understand why this idea will work. Okay, so for example, right, you have multiple activities. Okay, so now I'm going to use a bar chart to show you the different intervals. So for example, my first activity is between 1 and 2. Okay, then my next activity is between 1.5 and, okay, let's imagine there are decimal places, 1.5 and 4. Okay, so now for example, okay, for instance, I have a new activity, okay, that is 5 to 8. Okay, so notice that these two classrooms are both available, right? Okay, these two are both available because I can place 5, 8 into either of the classrooms. Maybe this is classroom 1, this is classroom 2. Okay, so but which classroom should I choose? I should actually choose classroom 2 because this number is the closest to the start value, which is the tree map or tree set, the lower method. Okay, so therefore I can just choose this classroom to place this activity in. So now you might ask me, so why can't I choose the first classroom? Okay, because, right, if I actually choose the first classroom, then what happens? I will actually have 5, 8 here, right? I have 5, 8 here. But then now if I give you another interval, okay, I give another interval that is 3 to 10. Then you notice, right, that 3 to 10 now has no classroom to place it in, correct? 3 to 10 now has no classroom to place in, and you will get a non-optimal approach. Therefore, this is wrong. Okay, you should place 5, 8 here so that you can place 3, 10 here. So notice at each step, right, what I'm doing is that I'm actually finding, given a start time, I search through, okay, which classroom has the latest possible end time that is still smaller than this start time. Okay, so that is the lower method in a tree map or tree set. Okay, so you just need to run this approach. Okay, basically you have all the classrooms, and each class, so basically you have a tree map or tree set, and you place in all the classrooms, and each classroom has its own, what's the endpoint of the last activity conducted. Okay, then after that you just run the dot lower to find the next classroom you place this activity in. Then you just run it, then you will get the most optimal allocation of activities. Okay, so this is how you solve this question. Okay, so this is basically using the idea of allocating activities in one classroom. Then now I extend it to n classrooms, and you need to use a tree map or tree set. So that's why this question is much harder. Okay, although the idea is similar. Okay, yeah, so this algorithm will run in O n log n. Okay, so I'm done with this question.